My name is Technical Sergeant Seth Tesse, 735th Air Mobility Squadron, Hawaii. Aloha. We are the low rollers, but easy rolling is our mission. Our team comprises of maintenance professionals from across the globe. From Europe to the Pacific, we know that maneuvering age is excessively strenuous for man and machine. Low rolling resistance tires, or easy rollers, can alleviate this. Anything heavier than a small toolbox is going to roll. Warfighters are suffering a death by 1,000 cuts, shoving sluggish equipment around the flight line. And back shops? Age Rangers are no strangers to heaving their equipment around. To add context, pushing a large truck into motion requires about 100 pounds of pushing force at your hands. An aircraft generator cart requires 250 pounds. Both items weigh around 6,000 pounds. Why the huge difference? It's because of the tires. We call this resistance. An aircraft generator cart uses an old forklift tire as standard equipment. Obsolete rubber chemistry causes 40% of this tire's rolling resistance. Its pneumatic design also makes the tire susceptible to flat spots, air leaks, and puncture. Modern forklift tires use short-chained sulfur compounds, optimized silica, and solid construction to achieve low rolling resistance and durability. They are also manufactured in pneumatic variants. The easy rollers that we tested made an aircraft generator cart nearly 50% easier to push than with standard tires. Commercially, this is called efficiency. We call it agility. Agile and robust tires support operational doctrines such as resilient forward basing and operational scheme of maneuver. There would be less manpower required for maintenance and maneuvering during sortie production. There are also efficiency gains. This is because of the reduction of drag, which optimizes the use of fuel or electricity. This means less fuel costs. For instance, you may be familiar with the new aerodynamic wiper blade that saves the KC-135 $7 million of fuel annually. Since introducing this into Vision, we have been contacted by several age shops eager to push this into the implementation phase. Although our immediate aim is to make easy rollers a suitable sup to some age TOs, we know that maintainers aren't the only ones who rely on tires. Already, Army engineers have expressed interest. Before moving forward, we ask for your continued support. Next is to collaborate with our testing cells to conduct the SAE age mobility test. If it's a good idea, let's roll with it. We look forward to your questions. But first, let us offer you one to think about. If the dream team is about to enter the court for the final game, what kind of rubber do you think they would lace up with? Crocs or Jordans?
All right, so hello, I'm Master Sergeant Wadaka. I'm an F-35 crew chief at RAF Lakenheath, and I'm presenting the project F-35 Realistic Composite Trainer on behalf of our team Staff Sergeant Gregory Collins, Master Sergeant Caleb McBride, and Tech Sergeant Cummings. The problem that we're trying to combat is that the misdrills cost the 48th MXG 90 days of aircraft downtime from June 2023 to June 2024. That's 90 days an aircraft was unable to support 9 F-35 taskings across EUCOM. If you can see in the photo, a misdrill is when you're extracting a stuck fastener. If you're not perfectly center, you will drill into either the panel and or the frame, and it causes extensive repairs or panel replacements that cost the Air Force between $50,000 and $300,000. And each instance has an average of 9 days of aircraft downtime. So our solution is the Realistic Composite Trainer for field training detachments. We want to update the training and allow low observable and sheet metal technicians the ability to develop their drilling proficiencies without risking the aircraft during their OJT. So that's currently how they're developing the skills to remove fasteners. The existing solution provided by Lockheed Martin, it costs $70,000 each. They're a poor representation of the aircraft, and they can't facilitate advanced training. Our solution, the Realistic Composite Trainer, has a current estimate of $15,000 each. And we started with a design from the aircraft. We scaled it down to desktop size. And the advantage is that this aircraft replicates the complex curvatures of the F-35, the difficulties with drilling on a low observable aircraft. This will provide a far more realistic and relatable training for the new airmen compared to the entry-level panel that they're using right now. So in comparison to the downtime at Lakenheath Luke Air Force Base has also experienced 12 missed drills during this time. We pulled a report for all the engineering requests since 2014, and there are over 500 fleet-wide action requests for missed drills. By applying our collected downtime average, that's a calculated 450 down days per year across the program. Every year, the F-35 program is eating over a year of collective downtime because of missed drills. We had the full support from the 372nd TRS commander, Lieutenant Colonel Huff. He's eager to get on board with the panels and get them into schoolhouses. The 48th MXG commander, Colonel Mink, is eager to get these panels to the MXG technicians, and he's funded the initial prototypes. We also brought in the F-35 JPO maintenance training device managers to help get us connections to make the panels. They're talking to people on their end. And the Hill Air Force Base Advanced Composites Lab is fabricating our first MVPs, and they'll develop the technical package, the final mold design, and they'll facilitate production through the Hill Air Force Base depot resources. So right now, our current estimated cost is $640,000. We're seeking an Air Force sponsor to fund this effort internally. Sourcing funding from the F-35 program for organic Air Force initiatives has historically been an uphill battle. Our projects get time-gated by bureaucratic processes that ultimately would extend this project until 2030. In the next 5 years, we're going to experience over 5 years of F-35 downtime. You would have to fund another aircraft to replace that if you want to get that back. The aircraft costs $85 million. For this $640,000 initiative, we can get that back. We can start chipping away at how much missed drills affect the F-35 fleet. And if we wait for the F-35 program to solve this problem for us, we're going to get this hyperinflated, inadequate solution, and it's going to be 5 years too late.
Thanks for being here. Today we're talking about Shinkasil, a small invention that is going to make a big difference. I'm Tech Sergeant Shane Strack, and I'm here with Tech Sergeant Darren Hernandez, Staff Sergeant Brandon Webb, and Senior Airman Zachary Flores, and we're from the 18th Wing at Kadena Air Base. Together, we built something that helps maintainers, saves money, and seals your future. Shinka means evolution in Japanese, and that's exactly what this is. It's a major evolution in how we protect our critical systems. Now, Staff Sergeant Webb, would you please tell us about the problem a little bit?
Right now, across maintenance operations, we're still using plastic bags and metal caps to cover fuel, hydraulic, and avionics components. It's not ideal. Bags tear and hold moisture, metal caps corrode and damage threads, and neither gives you a consistent protection. This leads to FOD risks, electrical damage, chemical corrosion, and a lot of wasted time. And quite frankly, it's frustrating. So, we built Shinkasil, a universal 3D printed seal that friction locks into openings without damaging them. It's made of TPU, meaning it's flexible, tough, and resistant to gasoline, JP8, other hydraulic fluids. The ribbed cone design fits both male and female ports, so you only need 5 sizes instead of hundreds of different plugs. And the hex space ensures it's easy to remove and can't fall inside pipes or fittings. Now, Sergeant Strack, can you elaborate on the ROI?
Absolutely. The impact that was had here was even bigger than we expected. The application time dropped from 12 minutes with metal caps down to just 4 with this Shinkasil. That's 67% faster and way less hassle. It's also crazy cheap. It's about 2 cents per piece when it's mass printed. Spark Cells can crank out these bad boys locally for about $328 a set, meaning units can stay stocked without waiting weeks for parts. And we're moving fast. Phase 1 secures System Program Office approval and assure it's compliant with the maintenance technical orders. Following Phase 2, scaling production through the Rapid Sustainment Office and getting Shinkasil into more bases. Finally, lock in the sustainment funding and open up the doors to civilian use. I'm talking automotive, industrial maintenance, and beyond. Now I know what you're thinking, how do I get involved? If you want to be a part of this evolution, or should I say Shinka, request a set through your Spark Cell, print it locally using an STL file and TPU filament, and that's it. All you have to do and make sure you get back to us. But most importantly, please share your results. Your before and after photos and feedback are gold for helping us scale smartly. You can scan the QR code using the link tree. it's all ready to go. Bottom line is, Shinkasil is simple, scalable, and mission ready. It cuts costs, reduces contamination, saves time, and makes life easier for the people who actually turn the wrenches. Thank you for your time, and let's keep pushing the Shinka forward.
Morning. My name is Todd Oldham. I am from the 309th EMXG at Hill Air Force Base. Our team, as you can see here on the screen, consists of William Adams, Brian Crosby, Cody Giddens, Stacy Justice, Kimberly Mullins, Braden Mulvey, myself, Samuel Shepard, Bailey Gilchrist, and Matthew Mosley. Our effort primarily revolves around the 309th EMXG at Hill Air Force Base in Utah and Support Center Pacific Air Force Sustainment Center's only current in-theater depot presence located in Okinawa, Japan, where we perform depot-level repair of line-replaceable units for a multitude of weapon systems. Too often, assets pulled off of an aircraft are not tested thoroughly enough before being sent to the depot, and usually those assets cannot be repaired in the field. This includes assets such as flight computers, HUDs, indicators, actuators, and more. This negatively impacts the readiness and availability of our aircraft by removing good assets from the field. On top of that, round-trip shipping of these assets takes an average of 8 weeks, not including the time it takes to test and repair these assets. Our solution is to use the Air Force's tester of choice, the VDATS. We want to create a portable, ruggedized version of the VDATS that can operate at all 3 levels of maintenance, meaning it can be used to perform anything from simple electrical troubleshooting up to and including diagnosing individual component failure on a complex circuit card. For example, an artisan could rapidly diagnose and replace a failed diode which grounded an aircraft, returning that plane to service in hours or days rather than weeks. By testing and repairing assets without sending them to the depot, we strengthen the Air Force's ability to execute agile combat employment concepts and operations. The VDATS platform is already being used in our depot, and we intend to use its existing architecture to speed up the development of a smaller, ruggedized version. This allows us to use software and hardware that have already been developed, tested, and fielded, providing us the capability to have any software we develop for the portable version be viable on the larger version as well. This commonality will significantly reduce the lifecycle sustainment costs for the new system. The VDATS platform can test multiple assets across various weapon systems, and with the right data, it can test just about any asset on any weapon system. As a highlight, the Automatic Test Systems, or ATS SPO, is on board with this project and are working collaboratively with us to ensure it is successful. This project will be 100% organically developed, maintained, and sustained. Some of the benefits we expect to see from this project are an elimination of approximately $3 million in shipping and the mitigation of damage or loss of assets during shipping. We aim to reduce shipping time, repair turnaround time, no faults found, and MICAPs. This leads to an overall increase in LRU availability and, above all else, an increase in aircraft availability and readiness. Our immediate plan is to create a prototype of the ruggedized portable VDATS to showcase its capabilities and improvements to readiness. Long term, we want the VDATS to be used across the enterprise for testing and repair at all 3 levels of maintenance. We are requesting $1.15 million to fund this project. This funding would get us to first article testing of the VDATS. In addition, we need a formal enterprise requirement to make this project successful. We have already received an initial requirements document for the F-15EX weapon system in support of this project, but we would like this project to be used enterprise-wide and not be unique to one weapon system. This project has the potential to be used not only across the Air Force, but other branches of the military as well. To support the global enterprise network for Universal Sustainment Initiative, we need to bring repair capabilities where they are needed most. Thank you so much for your time and for listening to our proposal. Please let us know if you have any questions.